Thanks, Matt. Morning, everybody. My name's Lee Gould. I'm from a company called Kimberly. We're a consultancy looking at the top part of the product development process, really. So we move in the innovation research space, looking at what's happening in terms of blue sky research, new products, innovation, regulation and standardization, and try and make some sense of that. Similar to what Martin does, really, I think. I was asked along today by Robin Tasker, as now I'm the chair of BSI IST 6 Datacomms. He thought it would be useful to present a view of the Internet of Things to you people here. And what I'll do is I'll present a very high level impression, I think, of my opinion of where IoT could be going. Okay, so what is the Internet of Things? It's many things to many people. It isn't one thing in particular, that's for sure. To some people, it's just a waste of time. Who wants a talking plant pot? To other people, it's a very useful concept and will form a key part of their business in the future. To me, it's really about connectivity of end devices. So if I can use this. Okay, so we have all the different devices around the edge here in different application domains that we're seeing. So we have energy, we'll have health, we have telematics, transport, building controls, even healthcare, and even smart sewers. That's very important. So we're going to get more data coming in, more sensors, but also the key part for me is the interoperability around these different sectors. So to be able to use equipment, ideas, the communications infrastructure, the data analysis across all these different sectors. Another little infographic. This one's from Intel this time, and it shows over time, moving upward here, an estimate of the number of connections, the type of connectivity, the number of devices interconnected. So fairly high in terms of devices up towards 2020. The key thing I want to point out really from this slide is that there is a definite blurring here of connectivity across different domains and devices. So people will start to expect this connectivity. Maybe they don't know it's there, but in terms of the services they're being offered, they would expect that. I want to look a little bit now about the momentum behind IoT, or as Cisco would have it, IoE, Internet of Everything. Just to see the forward push for this. At the moment, it's still very early days. There's a lot of fragmentation, as we'll see. But there are good arguments, I think, for making IoT work in some form in the future. So this is some data from IDC. So 30 billion connected devices by 2020. This is one of the numbers produced. They go down from 26 billion up to 50 billion, depending on the data that you see. The investment in ICT at the moment is growing at about 4% per year, expected to maintain that up to 2020. For IoT, that's increasing at 12% per year. So by 2020, there'll be about the same amount spent on traditional ICT as on IoT equipment. And the amount of data containers, it says here, data packets being sent around was around 8 quadrillion in 2010, going up to 4,200 quadrillion by 2020. So an awful lot more data being passed around, some small packets and some big packets. This is my personal view of a top-level architecture for IoT. So on the left-hand side here, we have the devices. I call them devices. So they could be sensors, they could be bits of equipment, it could be your smart washing machine, it could just be a proximity sensor, it could be a temperature sensor somewhere. any type of end devices. And then we have what I call the connectivity solutions, which is how these things are connected together, the different comms protocols at all layers of the stack. Applications platforms, here are the presentation of the information coming back to the user, or how that information is processed, and so on. But the key point here is this data gathering and mining part. So IoT, or having lots and lots of sensors out there, lots and lots of devices feeding information back into the system, means you're going to have an awful lot of data being produced. It's how to make sense of that data and how to add value to an application or to a system or to a proposal using that data. So that's the data gathering and mining part. And this is where the data can be monetized. This is where you can make money from that data, and being clever with how you analyze that. So for all these four areas, there are companies out there now and companies being started up, companies moving into these areas that see real growth potential here. Another point I want to bring out really is how things are changing in the tech industry. So a lot of large, traditionally consumer electronics oriented companies are finding it tricky now in the marketplace. They're finding that their key markets are being eroded, probably because of other companies from other countries starting to come up and offering cheaper goods. Perhaps they've reached the top of the S-curve when it comes to their particular product or their particular offering, and they're looking for new things to move into. At CES in January, the CEO of Samsung announced that they're really looking towards IoT to provide them with their next boost in their business growth. So traditionally that comes from the mobile platforms, their mobile phones and so on. That's now being eroded, and they're looking for something new to do. So by 2017, I think, the aim is to have sensors, or to have all the Samsung devices connected somehow. There's definitely growing device and apps market out there. We've seen that already with mobile phones, but that's also moving now into management for heating systems in the consumer space, certainly, and in health, definitely. This idea that gathering data, holding data, and also processing that data is a way of generating money is also a very strong driver. A key thing is this cross-sector collaboration. In order to do this stuff properly and to make money here, you need interoperability at various levels. And so this is a key point. And you see now what's happening is that a lot of key players are seeing the value of working together. Speaking of working together, this is a selection of the alliances now that are working on Internet of Things, probably the largest ones, I think. And what I've shown in the boxes are only the top level members of these organizations. So these are the drivers, the founders of the associations in the alliances. There are many, many dozens or hundreds of companies at lower levels of membership. So we have Open Interconnect Consortium, All Seen Alliance, and IPSO, Internet Protocol Smart Objects Alliances, all looking at the same sort of, roughly the same area of interoperability between devices, between communication systems, using, wherever possible, open standards, existing standards, or open source, if possible. 1M2M, the membership here is actually a set of telecommunication standards bodies or telecommunications associations. So these are very, very large and powerful organizations. Traditionally, M2M is machine-to-machine communication, it means. We're looking at specifically machine-to-machine, so maybe automation in factories and so on. But now that's moving out into a much wider space, more into the consumer area, into the living area, and so on. Thread is developing more or less its own protocols that sit above 802.15.4, so a lot of sits above an existing standard set of protocols. The thing here is that it's founded by Nest and Nest, as you probably know, were bought out by Google last year. Zigbee is a home automation system. It originally came out from home automation. Actually, now it's spread out into many, many areas, into energy, health, and home control, even into vehicles now. Very involved with smart energy, with smart grid. And there are many, many hundreds of members of Zigbee based on 802.15.4. And although not really an alliance as such, HomeKit from Apple. So Apple tends to make things more sexy in the marketplace and tends to push things forward certainly in terms of consumer products. So I've put them on there. So there's already a lot of momentum moving forward now in terms of this interoperability and reaching out and bringing in different players, bringing them together into a whole set of applications and comms protocols. Similarly, in standardization, we have international standards bodies now certainly getting involved in IoT, probably from a higher level, and these are two European entities that are also looking at that area. And they're probably less official, but still very, very important standards bodies from a global perspective as well, of course, are certainly very active in IoT. So again, this is my view, packaging things up a little bit, of a system, full IoT type of system. So using the same value chain as I showed in the previous slide. So this is an example here. This is the Hive system from British Gas, so you can remotely control your heating and your water from your mobile phone if you want to. It uses wireless devices in the home using Zigbee. It will talk out of your home onto the internet using standard internet protocols, of course, and your phone can access the server in the cloud using either protocols from 3GPP, 4G, 3G, or standard internet protocols. And you can access the information or the analysis of the data that you have from any internet-based machine. And an important part is that this is a very useful way of gathering information on behavior and consumption for British Gas. Another example would be to do with health. So you have some sort of device on your body. In this case, I'm showing a smart watch that is measuring something, maybe blood pressure. In this case, it's showing pulse, but it could be anything. And then connected out to some health type of application, maybe a hospital, maybe a remote monitoring service, to detect any particular anomaly in your system, your health system. And another one could be security. So security here is represented by a passive infrared detector, but of course it could be more sophisticated. Again, going out to a larger system. So at the moment you can get services and devices that will support any of these, really. But what you can't do is to blend them together. So the difficulty you have here is in the interoperability between these boxes, or even across the boxes, and especially security. So security and privacy, authentication, protection against attacks, and so on. So these areas are the key work areas, I think, of those associations that we saw earlier, and these are the problems that really need to be solved and sorted to allow a cross dissemination of behavior and capability of the much larger ecosystem that IoT offers in terms of its applications. Okay, so I am not an IT person. I don't manage large buildings and large sites, but I thought that maybe these areas would be of interest and significance to anybody who is involved with managing a large site. So obviously there's building management. Here we have energy to do with consumption, to do with understanding how energy is being used in the system, how much energy is being produced by the system as well, so kind of a smart grid type idea. Transport could be where are the empty parking spaces, what about the flow of traffic in and out of the site. Also Martin mentioned self-driving vehicles earlier. There'll be many, many sensors now on cars that are being put in there that will communicate with the internet out of their own environment. So also picking up on that type of data too, especially with electric vehicles in relation to charging, and also the charge levels in the cars. People flow, understanding what's happening at certain times of day, maybe being able to divert people around. We got fitness. Yeah, so Matt mentioned connected running machines and stuff. That's just the tip of the iceberg, I think. Now we have fit watches. Soon that will blend much more into health type apps as well. Maybe more for the worried well, but definitely there will be much more connectivity around in the not too distant future. Comfort means, okay, what's the temperature like, but also what about the level of oxygen in the room here? What about the level of CO and CO2? So being able to connect those up to health. Definitely, I think this will be a big area in the not too distant future for body area networking, for wearing health monitoring devices, but also maybe in the middle distance future, actually having devices embedded in your body, or nano devices moving around your body, and that information that they're collecting being collected probably by a smartwatch or something like that, and being sent out to a wider system. We have smart appliances, they're coming up now all the time. Connected kettle, okay, everybody poo-poos the idea of a connected kettle. Actually, from a smart grid perspective, it isn't so bad. But being able to connect up and to understand what's happening with the whole load of devices on the site, to understand when they're being used, maybe to understand about the servicing requirements and so on, is valuable information. Safety and security speaks for itself, I think. I'm really talking now about personal safety and security, I think. Typical internet type applications, so being able to access the internet to do whatever people do with the internet at the moment. And communications resilience is very key here. So what happens if one part of your network goes down? What happens if there are radio interferers suddenly come in? What happens if for some reason some link is broken? Can you mend that? Can you use an alternative scheme? What's the strategy for doing that? So these can sit as separate islands, but the real power of IoT means that you can start to use different applications, can use whole sets of these sensors, and can start to drive different applications. So in order to do that, then we certainly need reliable communications. So the comms has to work more or less all of the time. That's what people will start to expect. And that doesn't mean just having a nice 802.11ac system in the room, because judging from my personal experience, that may not be the most reliable of networks. Interoperability is absolutely key here. So interoperability, not necessarily at the lower levels of the comms, but certainly at the middle and the upper levels, definitely, to be able to share information, to be able to hop from one comm system to another, from one bearer to another. Definitely at the data level, most definitely at the data level, to allow different systems to access the same data, to have smart ways of analyzing that data. And then when you have that knowledge from the analysis, to be able to control the systems, to be able to control devices, signage, so to be able to direct people around the campus in a certain way, given certain safety conditions or certain alert conditions, and so on. And I think just here I want to give just a small example of the way that the power of understanding how data can be manipulated in different areas. So a few years ago, there was a heart surgeon, and he found that post-operative care was actually not as good as it might be. So a lot of people were having real trouble after having heart bypass operations and so on. The mortality rate was quite high. That was because it was difficult to monitor their signs in a timely way and to understand when things were going wrong. By chance, he had a meeting with somebody who understood about aero engines. And for aero engines, they have, in order to monitor that system, they have many inputs. There are many sensors on those devices. Lots of inputs, lots of data input, not really giving a full picture. Each one doesn't really give a full picture. It's a bit sketchy. But together, you can operate on that data. You can run algorithms on there that will give you a good picture of the health of that engine and predict what's going to happen in the future. So applying those types of rules to various key indicators on human beings post-operative means that then you can start to predict any trouble that will happen in the future. So they implemented that system, understood what needed to be monitored, so understood what type of sensors effectively needed to be read, and analysed the data and controlled certain other parts of the system, which meant that the mortality rate dropped to next to zero. It's very impressive. Okay, to conclude. So, what I want to say is that there are going to be many more devices out there connected. Whether people poo-poo the idea of IoT and the connected plant pot or the connected kettle, I think that the momentum now in the industry from all the main players is such that this will start to happen, it will start to take off. And it is happening already, actually. Many types of applications, most of which we don't know about now. The thing is that IoT, with its interoperability capability, will provide a fantastic platform for developing new platforms and new applications, and importantly, new business opportunities in the future. To do that, we have to have interoperability and a good, solid network to transfer that data around. The real value, I think, in IoT comes from the data analysis aspect and be able to control the wider systems from there. So that is a key point, whether that's on-site or off-site. Understanding about the behavior of your wider system is very important. So areas that you might wish to consider would be, okay, what's the quality of the comms link itself? So how big is it? How wide is it? What's the latency requirements? Different applications will have different latency requirements and so on. Can you move between different areas easily? Is your system resilient? Will the connectivity be maintained most of the time? Do you have a quality of service control in terms of prioritization and so on? So you're prioritizing maybe health type applications rather than where's the nearest parking space. And to be able to scale up. I think at the moment it's difficult to say how big this whole system will be, the requirements placed on the network will be. So it's important to feed in some scalability ideas too. Security is extremely important. Device authentication, when you bring a device into the system, is it real or is it a rogue device? Encrypting data, looking at data privacy, of course, and protection against attacks from outside. Being able to control devices in the system as well, maybe allowing guest access, bring your own type attitudes to different types of devices in the network or sensors. If someone drives on campus, someone gets a new watch, someone has a new smartphone, whatever we're calling them then. And also, there may be issues, legal issues or regulatory issues. Service level agreements may be required with external providers, maybe with health providers, energy providers, and so on, regarding the quality and the capability of your links and so on. So a very quick view, very top view, but I hope it's given you some insight into what is going to come up in the future concerning connected sensors and connected devices. Thanks.